August 3rd, 1944, Mortagne, France. SS Obersturmbannführer Otto Baum crouched beside his Panther Ausführung G, watching through binoculars as another American Sherman column rolled past his concealed position. He counted methodically, 37, 38, 39. He stopped counting when the column disappeared over the ridge, knowing more would follow. They always did. Baum's Panther was a technological marvel. Its 75mm KWK 42L/70 gun could penetrate any Allied tank at ranges exceeding 2 kilometers. Its sloped frontal armor, 80mm thick at 55 degrees, was effectively immune to the Sherman's 75mm gun at combat distances. In every measurable specification, armor, firepower, optical range finding, the Panther was superior. Yet Baum and his crew understood a truth that German high command refused to acknowledge. They could destroy 10 Shermans, and 20 more would appear. The mathematics of industrial warfare had rendered tactical superiority meaningless. What Baum couldn't know, what even Albert Speer only partially understood, was the magnitude of Germany's production catastrophe. While German factories struggled to produce 6,000 Panthers throughout the entire war, American factories were completing 50,000 Shermans. This wasn't just numerical superiority, it was industrial annihilation. The story of the Panther versus the Sherman is often told as a tale of quality versus quantity. The real story is far more devastating. It's the story of how Germany's pursuit of perfection guaranteed defeat, how democratic mass production buried aristocratic craftsmanship, and how America's embrace of good enough proved infinitely superior to Germany's obsession with perfect. The Panther emerged from panic. On June 22, 1941, Operation Barbarossa launched Germany into the Soviet Union with confidence. The Wehrmacht's Panzer, 3 and 4 tanks had dominated Poland and France. Soviet armor was expected to crumble. Instead, at 8:47 a.m. on June 23rd, near Raseiniai, Lithuania, a single Soviet KV-1 heavy tank blocked the advance of an entire German division for over 24 hours. The 50mm guns on German tanks bounced harmlessly off its 90mm armor. The revelation intensified throughout the summer. T-34 medium tanks appeared in numbers, demonstrating sloped armor that German designers had dismissed as unnecessary, and 76.2mm guns that destroyed Panzer IIIs at ranges where German tanks couldn't respond. By October 1941, German tank crews were requesting emergency upgrades. The Panzer Commission, a team of engineers sent to examine captured Soviet tanks, returned with sobering reports. Soviet armor was crude but effective, simple but producible, adequate but overwhelming in numbers. Everything German engineering philosophy was not. Hitler demanded immediate responses. On November 25, 1941, he ordered development of a medium tank incorporating lessons from the T-34 while maintaining German engineering superiority. The contract went to MAN, Maschinenfabrik Augsburg-Nürnberg, which promised delivery of prototypes by spring 1942. Daimler-Benz submitted a competing design that closely mimicked the T-34's layout. Hitler rejected it as too derivative. Germany would not copy inferior Slavic designs. Instead, the Panther would perfect the concept, combining Soviet innovations with German precision. This decision, prioritizing pride over practicality, would prove catastrophic. The Mayenne prototype appeared in September 1942, 15 months after specifications were issued. It weighed 45 tons, 10 tons heavier than planned. The Maybach HL 230 P30 engine, designed for 35-ton vehicles, struggled with the additional weight. The transmission, adapted from existing designs, was inadequate for the torque requirements. Test results were mixed. The 75mm gun performed brilliantly. The armor scheme was revolutionary, but mechanical reliability was abysmal. Engines overheated, transmissions failed, final drive units broke. Hitler, desperate for wonder weapons after Stalingrad, ordered immediate mass production despite these flaws. The first production Panthers left Sherman's Nuremberg factory in January 1943. Rather than resolving mechanical issues, production magnified them. Each Panther required approximately 55,000 man-hours to manufacture, double the time needed for a Panzer IV. The specialized components demanded precision machining that only skilled craftsmen could provide. Germany had plenty of engineers, but increasingly few skilled workers as casualties mounted. Mann's Nuremberg plant could produce 25 Panthers monthly at peak efficiency, rarely achieved. Daimler-Benz's Berlin plant managed 30 monthly. MHH, the Maschinenfabrik Niedersachsen-Hanover plant, added another 25. Total monthly production across all facilities peaked at 380 Panthers in July 1944. This was Germany's maximum output, with 3 major manufacturers operating at capacity, consuming critical resources, and employing thousands of skilled workers. Meanwhile, in Detroit, Michigan, Chrysler Corporation's tank arsenal was producing 800 Shermans monthly at its peak. A single American factory outproduced Germany's entire Panther program by more than 2 to 1. The Sherman had originated from different philosophy entirely. In September 1940, with France fallen and Britain besieged, the U.S. Army Ordnance Department began developing a medium tank that could be mass-produced using existing American automotive technology. The T6 prototype, later designated M4 Sherman, first ran in September 1941. It wasn't revolutionary. It wasn't intended to be. The Sherman was designed around American strengths. Continental radial aircraft engines were abundant, vertical volute spring suspension used, proven automotive components. The 75mm gun was adequate against current threats. Most critically, every component could be manufactured by automotive factories with minimal retooling. The Rock Island Arsenal approved the design in October 1941. Production began in February 1942. By July 1942, just 5 months after the first production, Sherman, 11 different manufacturers were producing the tank. Chrysler, Fisher Body, Ford, Pacific Car and Foundry, Pressed Steel Car Company, Baldwin Locomotive Works, American Locomotive Company, Lima Locomotive Works, Pullman Standard, Federal Machine and Welder, and Montreal Locomotive Works in Canada. This wasn't military production, it was industrial mobilization on a scale Germany couldn't comprehend. The Sherman's design prioritized producibility. The hull used simple flat plates, easy to cut and weld. The turret was cast in a single piece at facilities already casting engine blocks. The suspension components came from automotive suppliers. Training was simplified. American tank crews received 4 months of training. German Panther crews required 6 months minimum, often longer. The Sherman's reliability meant less maintenance training. Its automotive-derived components meant mechanics understood it intuitively. The Panther's specialized systems required technical specialists who were increasingly unavailable as the war progressed. By December 1943, American factories had produced 10,968 Shermans. Germany had produced 1,768 Panthers. The ratio was already catastrophic, 6 to 1, but the gap would only widen. The Battle of Kursk in July 1943 provided the Panthers' combat debut and revealed the consequences of premature deployment. Hitler demanded 250 Panthers participate in Operation Citadel, despite manufacturer warnings that mechanical problems remained unsolved. On July 5, 1943, 200 Panthers attacked as part of the southern pincer near Belgorod. Within 48 hours, half were destroyed or disabled. Most losses weren't from enemy fire, but mechanical failure. Engines caught fire, transmissions seized, final drives shattered. Oberst Karl Lorenz, commanding the 39th Panzer Regiment, reported that at one point only 10 of his 200 Panthers remained operational. Soviet anti-tank guns discovered that while frontal armor was impenetrable, the Panther's thin side armor, just 40 millimeters, was vulnerable. Soviet doctrine adapted immediately. Rather than engaging Panthers frontally, Soviet forces maneuvered for flank shots. The Panthers' poor crew ergonomics and limited visibility made it vulnerable to this tactic. More devastating was the realization that Germany couldn't replace losses. Those 100 Panthers destroyed or disabled at Kursk represented nearly 2 months of total production. The Soviets, meanwhile, were producing 2,000 T-34s monthly. Even when Panthers performed as designed, the mathematics doomed Germany. In contrast, the Sherman entered combat in North Africa during Operation Torch in November 1942. Early models proved vulnerable to German 88mm guns, but Americans responded with characteristic pragmatism. Rather than redesigning the entire tank, they developed the 76mm gun, which provided better anti-armor capability. They developed wet ammunition storage, reducing catastrophic fires. They improved armor on critical areas. Most importantly, they kept producing. By June 1944, D-Day, the production disparity had become apocalyptic. American and British forces landed with overwhelming armored superiority, not because individual tanks were superior, but because industrial capacity rendered individual superiority meaningless. On June 6, 1944, Allied forces landed with approximately 2,000 tanks supporting the invasion. German forces in Normandy possessed approximately 1,500 tanks total, including all types, not just Panthers. More critically, German logistics couldn't support sustained operations. Each Panther consumed 1.2 liters of fuel per kilometer. German fuel production, devastated by Allied bombing, couldn't maintain armored operations. Meanwhile, American logistics delivered 15,000 tons of supplies daily across the Normandy beaches. Fuel wasn't rationed. Ammunition was abundant. Replacement tanks arrived faster than they could be destroyed. During the Normandy campaign, German armored divisions discovered that killing Shermans was pointless when more appeared immediately. Kampfgruppe Piper, SS Panzer Division, Leibstandarte Adolf Hitler reported destroying 15 Shermans in a single engagement near Villers-Bocage. Intelligence officers noted that American columns showed no signs of depletion. New tanks, factory fresh, appeared within days. The production numbers from mid-1944 reveal why. In July 1944, American factories produced 1,854 Shermans. German factories produced 380 Panthers. The United States was outproducing Germany nearly 5-1 in medium tanks alone, while simultaneously producing thousands of other armored vehicles. Germany's maximum monthly Panther production, achieved once in July 1944, was 380 units. America's average monthly Sherman production throughout 1944 was 1,504 units. Peak monthly production reached 2,100 Shermans. The Germans weren't losing. They were being industrially annihilated. The Panthers' technical superiority became irrelevant against such overwhelming numbers. SS Hauptsturmführer Michael Wittmann, Germany's most famous tank ace, demonstrated this reality. On June 13, 1944, near Villers-Bocage, Wittmann's Tiger destroyed 14 British tanks and numerous other vehicles in a single engagement. British forces withdrew temporarily. Within 24 hours, British reinforcements arrived with more tanks than Wittmann had destroyed. Wittmann himself was killed on August 8, 1944, when 5 Sherman Fireflies, Shermans upgunned with 17-pounder guns, overwhelmed his Tiger through concentrated fire. The lesson was clear. Individual superiority meant nothing against systematic numerical advantage. By autumn 1944, the production crisis became existential. Allied bombing had forced dispersion of German industry into underground facilities. Mittelbau Dora and similar complexes used slave labor under horrific conditions. This wasn't just morally catastrophic. It was industrially counterproductive. Slave laborers sabotaged production whenever possible. Quality control collapsed. A Panther built in an underground factory by exhausted, malnourished prisoners had perhaps 50% probability of reaching combat before mechanical failure. Meanwhile, American factories operated 3 shifts with well-fed, well-paid workers, producing tanks with 99% reliability ratings. The same ideological blindness that prevented Germany from properly utilizing women in the workforce crippled tank production. American factories employed thousands of women in skilled positions. Rosie the Riveter wasn't propaganda. She was statistical reality. Germany, committed to Nazi ideology about women's roles, excluded half their potential workforce from industrial production. This wasn't just inefficient, it was suicidal. The Panther's logistical footprint revealed another critical failure. Each Panther required a supply chain of specialized parts manufactured by skilled workers using precision equipment. The Maybach engine alone contained 2,400 individual components. The transmission required specialized gears that only a few factories could produce. When Allied bombing destroyed these bottleneck facilities, Panther production collapsed. The Sherman, by contrast, used components from hundreds of suppliers. When one supplier was damaged, others filled the gap. The distributed production model proved resilient to disruption. German centralized production was fragile. By January 1945, German Panther production had fallen to 270 monthly, despite desperate efforts. American Sherman production remained above 1,200 monthly. The final production numbers tell the complete story. Germany produced approximately 6,000 Panthers between January 1943 and April 1945, 28 months of production. The United States produced approximately 49,234 Shermans between February 1942 and July 1945, 42 months of production. The ratio was 8.2 Shermans for every Panther. But raw numbers only begin to tell the story. Each Sherman required approximately 10,000 man-hours to produce. Each Panther required 55,000 man-hours. Germany was investing 5 times more labor for each tank produced. Germany manufactured 6,000 Panthers using 330 million man-hours. America manufactured 49,234 Shermans using 492 million man-hours. America invested 50% more total labor, but produced more than 8 times more tanks. American labor productivity was roughly 12 times higher. This productivity gap wasn't accidental. It reflected fundamental differences in production philosophy. German manufacturing emphasized craft precision. Each tank was individually finished. Components were hand-fitted. Workers took pride in perfection. This approach produced superior individual vehicles but couldn't scale to mass production. American manufacturing emphasized systematic efficiency. Components were standardized to tight tolerances. Assembly line techniques allowed semi-skilled workers to produce precision results. Quality control focused on functional performance rather than aesthetic perfection. The result was tanks that worked reliably, could be repaired quickly, and could be produced in overwhelming numbers. The maintenance comparison reveals another crucial advantage. Shermans used automotive-derived components. Trained mechanics could diagnose and repair problems using skills learned on civilian vehicles. Parts were interchangeable across manufacturers. A Continental engine from a Chrysler-built Sherman could replace a Ford GAA engine with minimal modification. Panthers used specialized components unique to the vehicle. Maybach engines couldn't be substituted. Transmissions required factory-trained specialists. When these specialists were killed, their knowledge died with them. By March 1945, American armored divisions were reporting tank availability rates exceeding 90%. German armored divisions reported availability rates below 40%. This wasn't primarily due to combat damage, but maintenance problems. Panthers were being abandoned intact because repair parts didn't exist and trained mechanics were casualties. The final campaigns demonstrated the culmination of industrial superiority. During the Rhineland campaign, February to March 1945, American forces employed over 4,000 tanks. German forces opposed them with perhaps 1,200 tanks of all types, fewer than 400 Panthers. American forces could afford to use tanks aggressively, knowing losses could be replaced. German forces hoarded their remaining Panthers, knowing each loss was irreplaceable. When Panthers were destroyed, crews who survived had no new tanks. When Shermans were destroyed, crews received replacements within days, often hours. The psychological impact of this disparity shattered German morale. Tank crews who destroyed multiple Shermans felt no satisfaction when more appeared immediately. The endless supply of American armor became more demoralizing than individual combat defeats. Albert Speer's memoirs, written after the war, acknowledge the production catastrophe. He calculated that Germany invested as many resources producing 6,000 Panthers as America invested producing 30,000 Shermans. The inefficiency wasn't just in assembly, but in the entire supply chain. Germany's pursuit of technical perfection created bottlenecks at every level. The ideology that rejected good enough as defeatist thinking guaranteed defeat. Post-war interrogations of German officers revealed consistent themes. They praised the Panther's technical qualities while acknowledging that numbers overwhelmed quality. General Oberst Heinz Guderian told interrogators, "The Panther was the finest tank of the war, but we needed 4 Panzer IVs for every Panther we built. Instead, we built Panthers and lost the war." General Feldmarschall Albert Kesselring was more direct. American industrial capacity made tactical skill irrelevant. We could win every battle and still lose the war. We did. Modern analysis confirms these assessments. The Sherman wasn't inferior. It was adequate, which in total war proved far superior to perfect. Its 75mm gun could defeat German medium tanks at combat ranges. Its armor protected against most threats. Its reliability meant it fought when needed. The Panther's superiority was real but tactically irrelevant. A Panther that could kill 10 Shermans didn't matter when 20 Shermans existed for every Panther. A Panther with superior armor didn't matter when American doctrine emphasized combined arms. Artillery, air support, and infantry would defeat Panthers without risking tank versus tank combat. The final irony is that American tankers respected the Panther's capabilities without fearing them. They understood that American industrial power guaranteed victory regardless of individual engagements. German tankers feared the Sherman not for its capabilities, but for its endless availability. The story of the Panther versus the Sherman is ultimately the story of 2 different approaches to industrial warfare. Germany pursued excellence, crafting superior weapons that demanded skilled labor, specialized components, and careful maintenance. America pursued adequacy, building weapons that worked reliably, could be produced in overwhelming numbers, and could be maintained by ordinary soldiers. In the end, adequate weapons produced in overwhelming numbers defeated excellent weapons produced in inadequate numbers. The mathematics of industrial warfare proved far more decisive than the mathematics of ballistic performance. Germany learned too late that in total war, the factory was as important as the front line, and America's factories had already won the war before the first Panther fired a shot in anger. The human cost of Germany's production failure manifested in the experiences of individual crews. Obergefreiter Hans Becker served as a Panther driver from August 1944 until his capture in March 1945. His unofficial diary, discovered decades later, provides haunting testimony to the production catastrophe. In 7 months of service, Becker crewed 4 different Panthers. The first suffered transmission failure after 80 kilometers, abandoned near Aachen. The second took a Sherman round through the side armor during the Battle of the Bulge. 3 crew killed. The third ran out of fuel during the Ardennes retreat, destroyed by its own crew. The fourth was captured intact when fuel shortages prevented any movement whatsoever. Becker wrote on February 12, 1945, "We receive the finest tanks in the world. They break before we reach combat. The Americans receive adequate tanks. They arrive in endless supply. Our commanders speak of quality over quantity. Our dead comrades prove this is a fatal delusion." The contrast with American crew experiences was profound. Staff Sergeant Robert Early of the 3rd Armored Division crewed Shermans from Normandy to the Elbe River. His tank, nicknamed Cobra King, was damaged 3 times, repaired twice within 24 hours, once within 6 hours. Early's memoir describes the psychological advantage of knowing replacement was guaranteed. "We took risks German crews couldn't afford," Early wrote. "If our tank was knocked out, we'd have a new one by morning." German crews knew each loss was probably permanent. That knowledge made them cautious. Our confidence made us aggressive. Industrial power created tactical boldness. The Battle of Aracourt in September 1944 demonstrated this dynamic perfectly. The German 5th Panzer Army, equipped with approximately 260 Panthers and Panzer IV, attacked the American 4th Armored Division with 180 Shermans. German doctrine, tactics and equipment were superior, yet over 17 days of fighting, the Americans destroyed 281 German tanks while losing only 48 Shermans. The explanation wasn't superior American tactics or crew skill, it was operational sustainability. Every destroyed Sherman was replaced within days, often from local depots. Crews remained fresh, rotating to new tanks. German crews, even when surviving vehicle loss, often had no replacement tanks. Experienced crews were reassigned to infantry. The institutional knowledge they carried died with their tanks. Colonel Bruce Clark, commanding Combat Command A of the 4th Armored, understood the mathematics perfectly. In his after-action report, he noted, "The enemy fought skillfully with excellent equipment." But we could afford to trade tank for tank. They could not. After 10 days, we had more tanks than we started with. They had perhaps 40% remaining. The outcome was predetermined by Detroit, not by battlefield performance. This same pattern repeated across every front. In Italy, during the Gothic Line battles, German Panthers dominated individual engagements. Yet Allied forces advanced because destroyed Shermans were replaced faster than they could be destroyed. In the Pacific, though Panthers never appeared, the Sherman's production advantage proved equally decisive. Japan's Type 97 Chiha tanks were inferior even to the Sherman. But Japan faced the same production impossibility Germany confronted. They produced approximately 2,500 medium tanks total during the war. America was producing more than that every 2 months. The production crisis intersected with Germany's fuel shortage in ways that multiplied the catastrophe. Each Panther required 1.2 liters of fuel per kilometer. In ideal conditions, with a full 720-litre fuel load, a Panther could travel 600 kilometers, but ideal conditions never existed. Combat operations, rough terrain and evasive maneuvers doubled fuel consumption. Realistically, a Panther consumed its fuel load after 250 to 300 kilometers of combat operations. American logistics delivered fuel in abundance. German logistics, crippled by Allied air superiority and bombed refineries, could barely maintain defensive operations. By late 1944, German armored divisions were receiving perhaps 30% of required fuel allocations. Panthers sat immobile not from mechanical failure, though that remained common, but from empty tanks. Entire panzer divisions were destroyed, not in combat, but by fuel starvation. The 9th Panzer Division lost 47 Panthers during the retreat from France. 32 were abandoned intact for lack of fuel. Only 15 were destroyed by enemy action. This ratio, 2/3 lost to logistics rather than combat, typified Germany's final year. Meanwhile, American armored divisions consumed fuel without restriction. Supply convoys delivered thousands of gallons daily. If local supplies proved insufficient, air transport filled gaps. The Red Ball Express, the famous truck convoy system, consumed more fuel in its own operations than entire German panzer armies received. The maintenance burden multiplied Germany's disadvantage. A Sherman required approximately 20 hours of maintenance per 100 hours of operation. A Panther required 60 hours of maintenance per 100 hours of operation. This 3-to-1 ratio meant German maintenance crews were perpetually overwhelmed. American maintenance companies could keep 5 Shermans operational. German maintenance companies could keep fewer than 2 Panthers operational with the same manpower. The complexity extended to every system. The Panther's interleaved road wheel design, which provided superior ride quality, created maintenance nightmares. Replacing an inner road wheel required removing multiple outer wheels. In Russian winter conditions, frozen mud made this task require 8 to 12 hours. The Sherman's simple vertical volute spring suspension allowed road wheel replacement in under an hour. German tankers joked bitterly about this design choice. "We have the best suspension in the world," went one popular quip, for the 30 minutes before it breaks. The interleaved wheels collected mud, debris, and snow. In winter, this mixture froze overnight into solid masses. Crews spent hours each morning chipping away ice before the vehicle could move. Shermans, with exposed wheels, simply started and moved. These seemingly minor design differences accumulated into strategic disadvantage. An American armored division could move 100 kilometers, service their vehicles, and be ready for combat the next morning. A German panzer division might spend 3 days covering the same distance, then require 2 days of maintenance before combat readiness. The training pipeline revealed another critical American advantage. Sherman production was so abundant that American training facilities possessed hundreds of tanks for instruction. Recruits trained on the exact vehicles they'd crew in combat. They learned maintenance on real Shermans, not mock-ups. German training facilities, desperate for every combat-capable Panther, used obsolete Panzer IIs and IIIs for training. New crews arrived at their units having never sat in a Panther. Their first experience with the vehicle was in combat. This training deficit killed German tankers. American crews arrived with 400 hours of training, including 100 hours on Shermans. German crews by 1945 arrived with perhaps 150 hours total training, virtually none on Panthers. The learning curve was steep and bloody. American after-action reports noted that German Panthers frequently retreated after receiving minor damage that shouldn't have caused withdrawal. Interrogation of captured crews revealed they often lacked the technical knowledge to assess damage accurately. A severed antenna made them assume radio destruction. A jammed periscope made them believe the turret was damaged. American crews, thoroughly trained on their vehicle's systems, could distinguish minor damage from critical failures. They remained in combat unless genuinely disabled. The industrial production model also created a virtuous cycle for American forces. Combat experience rapidly fed back to factories. Problems identified in North Africa were corrected in later production runs. The Sherman's evolution from early M4A1 models to late M4A3 E8 models with HVSS suspension and 76mm guns reflected continuous improvement. Germany's centralized, craft-oriented production couldn't adapt as quickly. Design changes required months of planning. Implementing changes across multiple manufacturers proved nearly impossible. When improvements were made, like the Panther AUSF-G's simplified hull design, the changes came too late to affect more than a few hundred vehicles. The post-war accounting tells the final story. America spent approximately $40,000 per Sherman in 1940s dollars. Total Sherman program cost was roughly $2 billion. Germany spent approximately $100,000 per Panther in equivalent currency. Total Panther program cost exceeded $600 million. America spent 3 times more money to produce 8 times more tanks. The efficiency ratio was nearly 25-1. These economic realities meant that even if Germany had possessed unlimited raw materials, which they didn't, they couldn't have matched American production. The industrial systems were fundamentally incompatible. German craft production couldn't scale. American mass production couldn't stop. When German veterans encountered American industrial capacity firsthand as prisoners of war, the psychological impact was devastating. They saw factories, supply depots, and training facilities operating at scales they believed impossible. One captured Panther commander, shown an American tank depot with over 1,000 Shermans awaiting deployment, reportedly said, "Now I understand why we lost. You don't just defeat an army like this, you bury it." The legacy of this production battle shaped post-war armored doctrine. No nation afterward pursued the German model of small numbers of perfect tanks. Instead, the Sherman's model, adequate platforms produced in reliable numbers, became universal. Modern main battle tanks are sophisticated, but producibility and sustainability remain primary considerations. The German military, rebuilt as the Bundeswehr in the 1950s, explicitly rejected Panther-style philosophy. Their Leopard tank emphasized reliability and maintainability over maximum performance. The lessons of 6,000 Panthers versus 50,000 Shermans had been learned. The Soviet Union, despite developing excellent tanks like the T-34/85 and IS-2, maintained the production-first philosophy. Soviet doctrine explicitly stated that adequate tanks in overwhelming numbers trumped superior tanks in limited numbers. This philosophy, learned partly from observing American production, guided Soviet armored development through the Cold War. Today, military historians recognize the Panther versus Sherman comparison as a perfect case study in the difference between tactical excellence and strategic effectiveness. The Panther was tactically superior. The Sherman was strategically decisive. In the end, wars are won by strategy, not tactics, by factories, not just fighting, and by realistic assessment of capabilities rather than ideological commitment to perfection. Germany built 6,000 Panthers pursuing excellence. America built 50,000 Shermans pursuing victory. The numbers tell the story. Democracy and industrial pragmatism buried aristocratic perfectionism under an avalanche of adequate but overwhelming production. The Panther was Germany's finest tank. The Sherman was America's war winner, and that made all the difference. The final lesson resonates today. In great power conflict, industrial capacity and sustainable production matter more than platform superiority. The nation that can produce adequate weapons in overwhelming numbers will defeat the nation that produces perfect weapons in inadequate numbers. Germany learned this truth too late, at the cost of everything.